So now it's live. All right. So copy out this example if you're at home. All right. So this is the only example we're going to do today. It's find the coordinates of the horizontal and vertical tangent lines. So if I kind of come back to the circle, a horizontal tangent line, we've done that before. That's where the derivative is 0. A vertical tangent line, the derivative's got to be what? So what's the slope right here? We have a vertical line. The slope is
0.
Horizontal lines, the slope is 0. Vertical lines, D and E. Slope does not exist. Sorry.
Okay, next time.
All right. So if you want to find out where there's a horizontal tangent, that's where the derivative is 0. And if you want to find the vertical tangent line, no, it's Christmas tree red. That's where the derivative does not exist. Okay, so I want to find in this implicit function here where that happens. So I'm going to first find the derivative. What's a good derivative color? I know it's green, but I'm going to separate horizontal and vertical as green and red. So what's a different color for today? Purple it is. Okay. So we're going to do the implicit differentiation, take the derivative of both sides. So I'm going to ddx both sides. And then once I get that, I got to find out when it's 0 and when it does not exist. So if I take the derivative, what's the derivative of the y cubed part?
3y squared.
Close.
3y squared
Times y prime, which is dy dx. The derivative of y squared is
2y dy dx.
perfect. The derivative of negative 5y is close. dy dx. And the derivative of x squared is
2x.
And the derivative of negative 4 is 0. So if you remember our steps, remember I said collect all your dy dx terms on one side?
Yeah.
So I'm going to leave these 3 pieces here. There's only one thing to bring to the other side. That's the minus 2x. So just add 2x to both sides. What's left over here is a dy dx. I'm just going to factor it out. So I have 3y squared plus 2y minus 5, factoring out the dy dx, equals negative 2x. Excuse me, positive 2x. If I want to find dy dx, I just got to divide both sides by that piece, and I'm done with the derivative piece. So those cancel out. So now I found the derivative. So phase 1 complete. So now I want to find out where there's a horizontal and vertical tangent line, and I'm going to start off with the horizontal tangent line. So there's going to be a horizontal tangent line when the slope is 0. So I want to find out when does this thing equal 0. So I'm going to rewrite the derivative. And make it equal 0. What did you just solve that?
Multiply both sides.
By what?
The denominator.
Sure. So if you multiply both sides by the denominator, what happens when you multiply the right-hand side by the denominator?
It just gets to the 3y squared.
Times 0 is...
Oh, 0.
So we really just need to know when does the numerator equal 0.
At 0.
Done.
0.
So at x equals 0, we're going to have a horizontal tangent line. But remember that the derivative depends on x and y, so we need to find the y value too, because there could be different y values at that particular x value.
Yeah.
So what we're going to do is we're going to plug 0 back into the original equation and solve for y.
Okay.
So I'm going to rewrite this equation, but replace x with 0. So y cubed plus y squared minus 5y.
Oh, the original?
The OG, not the derivative.
Okay.
Oh, yeah.
Why is that?
Because I'm trying to find a point on the equation, so I need the original equation to find where the points are.
Oh, so if you do the derivative, you won't.
Then you're dealing with slope, and I'm not interested in the slope. I'm interested in what y value does this occur.
Oh, okay.
So the x value is 0. The y value is, well, that's what I'm trying to find.
Okay.
So what I'm going to do is, this is a cubic equation. The 0 is not really doing anything, right?
Yeah.
We don't really solve cubic equations by hand. You've done the quadratic formula. There actually is a cubic formula. I'm never going to ask you to do it. I'm never going to do it unless it factors nicely, which this isn't factoring at all. So I just use my calculator to find it, and I can show you how to do it on the calculator. You could either find the intersection of these two graphs, or set it equal to 0 and find the x-intercept, and that'll tell you the solution. Either way, the answer ends up being negative 3.06.
Wait, so what do we do if we need to find it on our own?
Use a calculator.
So we literally just plug that in?
So there's ways to do it on your graphing calculator. If I were to Desmos it, instead of using y, I'm just going to use x, but the solution won't change. It was y cubed plus y squared minus 5y. So it says equals negative 4.
Okay.
Thank you. Equals negative 4, right?
Yep.
Yeah.
All right, so let's see if it'll actually work. I'm just gonna let that be my first equation, and then my second equation be y equals negative 4. And I think negative 3.061 was the answer that we got.
Oh, so you find it out on Desmos?
Yeah.
Okay.
If I were to give you a problem on a test, I'm not gonna make the solving part that difficult.
Okay.
What most people would do is, you know how this thing was originally negative 4?
Yeah.
You would just add 4 to both sides. So this would be plus 4 equals y, and then you're just finding the 0, which is still negative 3.06.
Okay.
Either way, so that's what we get for y. So where do we have a horizontal tangent line? It's at this point right here, 0, negative 3.06. Okay. All right. To find a vertical tangent, that's when you have the slope of a vertical line. That's when, whatever over here. That's when the slope, which we call the derivative, does not exist. And the derivative we got was this.
Okay.
So that's the derivative.
Mm-hmm.
When does that not exist? How do you figure that out? What do you need to know? In this case, when the denominator is 0.
Oh, that's gonna be hard to find.
So this does not exist when the denominator equals 0. Does anyone have quad form?
Trevor.
You know I got one for.
Can you do the quadratic formula here? This one doesn't factor nicely.
Wait, is
Okay.
there supposed to be an equal sign between the little fraction and the DNA?
It's weird to say something equals does not exist.
Okay, I'm ready.
Right.
Okay.
It's like 2 plus 1 equals does not exist. Like it, I don't know. Like it feels weird to say it. So I didn't want to write an equal. But like, yeah, I'm kind of finding out.
When it is.
Yeah. I don't know. I don't have a better notation for you.
3, 2, negative 5.
3, 2, negative 5. Yeah.
All right. I got 1 and negative 1.66666667.
So it's when y equals 1 and when y equals I think I got negative 5/3.
Yep.
Which is negative 1.6666. Okay. So
Question.
I now know the y. What's up?
How are we supposed to find that if we don't have quad form in our
Quadratic formula: negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So now I know the y values where you have vertical tangent lines. The next question is, what's the x value? What's the corresponding x value? So how did we find that before? Plug it into the OG equation. But we have to plug in 1 to the OG equation, get some x values, and then go back and plug in negative 5/3 into the original equation, find the x value. So it's going to happen at more than one spot. Okay. So the original equation up here, it's going to be y cubed, so that's going to be 1 cubed plus y squared, so that's 1 squared, minus 5 times 1 minus x squared equals negative 4. So I just plugged in the original equation. I plugged 1 in for y. We good so far?
Mm-hmm.
Okay, let's just zoom in on this, John. So this one looks a lot easier to solve, though, right? It's not a cubic. It's just a regular x squared. We're just going to end up doing a square root at some point. So this becomes 1 plus 1 minus 5 minus x squared equals negative 4.
Mm-hmm.
So 1 plus 1 is 2. What's 2 minus 5? Negative 3. So I have negative 3 minus x squared equals negative 4. I'm going to add the 4 to both sides and add the x squared to both sides. So I'm going to get x squared over here. And if I add 4, I'm going to get 1.
Oh, I did that, but I didn't.
You probably sort of added 3 to both sides,
Yep.
and then divided both sides by negative 1.
Yep. Same thing.
We both got x squared equals 1.
Yep.
So what does x equal? Stop it. I know it's almost Christmas.
Oh. Plus or minus 1.
A lot of people on that quiz, I remember, got that wrong. So we have right now 2 points where we have a vertical tangent line at x equals 1, y equals 1, and x equals negative 1, y equals negative 1. I'm going to write them all down in a second, but right now we have 1, 1, and negative 1, 1.
Oh, yeah.
Okay.
Which is what? That's the vertical.
That's where you have the slope doesn't exist at those points. It's a vertical tangent line.
Okay.
Okay. So now I have to do the same thing, but instead of plugging in 1, I'm going to plug in negative 5/3.
Okay.
So it's going to be negative 5/3 cubed plus negative 5/3 squared minus 5 times negative 5/3 minus x squared equals negative 4. I worked it out, leaving everything as a fraction. You guys want to just do it that way? Or do you want to just me tell you that it's plus or minus 3.237?
No, let's work it.
All right. So let's work it out. Negative 5 over 3 cubed, it's going to stay negative. 5 cubed is 125. 3 cubed is 27. Negative 5 over 3 squared is going to be positive because you're squaring a negative number. It's going to be 25 ninths. This double negative is going to be plus again. 5 times 5 is 25, so we got 25 thirds. What I'm going to do is add the 4 to both sides, so I have a plus 4. And then add the x squared to both sides, so I have a positive x squared.
Wait.
Okay, common denominator time. I need a skinnier. Come on. Oh. So the common denominator is going to be 27, right?
Sure.
the denominators are, I guess, 1, 3, 9, and 27. All right, so this one's good as it is. This one I'm going to need to multiply the top and bottom by 3. This one I'm going to need to multiply the top and bottom by 9. And this one by 27. Okay, so now my denominator is going to be 27. So I have a negative 125. What's 3 times 25? 75? 9 times 25? Is it 225? Yep. And 4 times 27? 108. Okay. So 108 plus 225 plus 75 minus 125. That is 125. So that's 283. 27ths equals x squared. So square root both sides. Oh, we'll keep it red. Square root both sides. So you got x equals plus or minus that fraction, which we're going to approximate, is about plus or minus 3.237.
So now there's what, 4 points where there's a vertical?
Yep. So, what did I write over here on the right side? Come on, computer. Come on, OneNote. There we go. So so let's zoom in again. So the vertical tangent line
So the vertical tangent line.
are at, so I'm gonna have to zoom out a little bit. Come on, computer. So we have when x is 1 and y is 1, and we have when x is negative 1 and y is 1. So we have 1, 1 and negative 1, 1, right? When y is this value here, we got 2 different x values.
Mm-hmm.
And then when y took on the value of 5/3, we had 2 different x values. So when x is positive 3.237 and y is negative 5/3, and when x is negative 3.237 and y is negative 5/3.
Holy moly.
Now, you all probably just believe me, but it's like building a telescope and never looking through it. Don't you want to see the function?
Huh?
Don't you actually want to see the function and see if we're right?
Yeah. And decimals. Can I tell my water while you insert out one?
It's our I have it right here.
Whoa.
So a super cool graph of the equation that we just worked with. Where did you go? Maybe you could have. All right. So according to our answer, there's 2 places where we have there's only 1 point where we have a horizontal tangent, and we said it's at the point 0, negative 3.06, right?
Yeah.
So at 0, negative 3.6, does it seem like we have a horizontal tangent line?
Yep.
Pretty sick.
What is that?
So that's at 0, negative 3.06.
Yep.
So that checks out. And then we said we had 4 vertical ones. We have one at 1, 1. Does it seem like we have a vertical tangent line here?
Mm-hmm.
What about at negative 1, 1?
Mm-hmm.
What about at a little more than 3 and negative 5/3? So here's 3. It's a little more than 3. And what was 5/3 as a decimal? Negative 1.666. Was that what it was?
Mm-hmm.
So here's 1. Yep, that seems to check out, right?
Yeah.
And do we have another one at negative 3.2?
Yes.
Yeah.
Yep. So it checks out that we did it right.
Okay.
Awesome.
All right.
May I fill up my water?
You're all set. Feel free to like, follow, subscribe, ring the
Hey,
bell for
hey,
notifications.
Dylan, I love you.
This video is brought to you by Raid Shadow Legends. Sign up today.